Hello, my name is Dan O'Connell. I'm the Vice President of Sales US for FiberStar. In this webinar, I will be talking about Citri-Fi natural citrus fiber and its many unique functionalities that make it superior versus other citrus fibers and ingredients in the marketplace. When I'm out visiting various companies, the first question teams ask is, why Citri-Fi? The ingredient market is a crowded place, so it's important to understand what Citri-Fi citrus fiber is, what it does, and why it should be considered first amongst all the options available. First, let's talk about Citri-Fi itself. Citri-Fi is created using a patented process that opens the fiber up to create natural high water holding capacity and emulsification properties, which benefit multiple food products. Citri-Fi can be labeled as citrus fiber, citrus flour, or dried citrus pulp, which resonates well in the clean label and natural markets. The high functionality is due to the intact native pectin that resides in the citrus fiber. This also differentiates Citri-Fi from other similar products in the marketplace. Citri-Fi also works synergistically with other hydrocolloids like starches and gums to provide additional functionalities, improve nutritional profiles, and offer potential cost savings. Because of the simple labeling, Citri-Fi can help clean labels of food products by replacing or reducing other ingredients such as modified starches, gums, allergens, and others including saturated fats and phosphates. Finally, Citri-Fi has no E number, which is a benefit in the European markets. And this natural citrus fiber is non-GMO project certified, allergen-free, gluten-free, and contributes fiber to the nutritional labeling. Citri-Fi sustainability starts with the raw material supply, which is byproduct from the citrus juicing industry. This is unlike other suppliers in the market who produce their product from processing pectin. This upcycled citrus fiber is created from a patented process that is free from chemical modifications, but uses mechanical forces to open up the fibrous cell wall material. This process loosens and opens the tightly bound soluble and insoluble fibers and protein to create an expanded fiber matrix. This material is then dried and milled into a free-flowing powder. The nutritional composition is preserved, which allows it not only to contribute fiber, but also reduce ingredients that have a higher environmental impact, like egg, fat, and animal meats. Citri-Fi contains over 70% fiber, depending on the product. This fiber is half soluble fiber that contains native pectin and half insoluble fiber and protein. The soluble fiber attracts the water, binds it, and provides viscosity. The insoluble fiber provides the structure to hold the water indefinitely. The protein helps in binding fat and oil to stabilize emulsions. These benefits are novel since there are very few ingredients in the marketplace that can bind both water and/or oil naturally, even during harsh food processing conditions such as freeze-thaw. FiberStar has 9 product types that are differentiated by composition and/or particle size. The workhorse products, the 100 series, contain only the citrus fiber. Certain applications may require additional viscosity, so we recommend Citri-Fi 200, which is citrus fiber co-processed with guar gum, or Citri-Fi 300, which is citrus fiber co-processed with xanthan gum. Due to all of its beneficial functionalities, Citri-Fi improves a variety of food applications, including those listed here on the slide. Citri-Fi holds 9 to 10 times its weight in water. In this demonstration, we use 10% of the Citri-Fi 100, which is not a typical usage level. This high level is used to showcase the Citri-Fiber's high water holding capacity. We recommend using the Citri-Fi citrus fiber between 0.2 and 1% in most food applications. Here, in a small jar, we have 180 mils of water. We add 20 grams of the Citri-Fi 100 into the jar of water. Using a stick, we stir until all of the water is absorbed into the fiber. During the stirring action, the fiber swells to create thickness and viscosity. This water binding holds the water tightly in a food product, even during the harshest conditions and storage over time. Citri-Fi's water holding is proven out here. We tested various commercial fibers in the market, including carrot, wheat, cottonseed, tomato, and oat, to name a few. Citri-Fi 100 holds almost 5 times more water than the oat fiber tested, and almost 2 times more than the wheat fiber, which are both widely used in the industry. The other perk is that Citri-Fi holds onto the water even during the most adverse conditions, such as heat and freeze-thaw, which is not the case for most of these other fibers. This benefit is further proven when tested in a food application. In this scenario, we tested the Citri-Fi in a cooked meatball. The test demonstrates that Citri-Fi not only holds on to the most water per gram as is, but also holds on to more water per gram after the meatball cooking process, compared again to the other fibers tested. Water holding is not the only feature. As mentioned, Citri-Fi also provides excellent emulsification stabilization properties. Since this Citri fiber uses various mechanisms to create the emulsion, a standard HLB test cannot be used. As the result, FiberStar created a test to measure the relative oil holding capacity for each stabilizer. This test creates emulsions using various emulsifiers and stabilizers. After hydration, the emulsions were mixed with some shear and then centrifuged. The results were measured by gram of oil per gram of stabilizer to create an index. Here you can see that Citri-Fi produces indexes that are significantly higher than its competing counterparts. For instance, Citri-Fi holds 5 to 8 times more oil than certain oat fibers. Here, we will demonstrate Citri-Fi's natural emulsification properties. This demo uses oil at 3 times the Citri-Fi weight and water at 10 times the Citri-Fi weight. The Citri-Fi is mixed into the oil first, which is one method we recommend. We fill the jar with 15 mils of oil and pour 5 grams of Citri-Fi into the oil. The mixture is then stirred until all of the fiber is coated with oil. Next, we pour about 50 mils of water into the oil and fiber mixture. We shake the jar until an emulsion forms, which takes about 15 seconds, or until the sloshing goes silent. During the shaking or mixing step, the fiber hydrates and swells to create the viscosity and emulsion. Here, we showcase another demonstration of Citri-Fi's ability to bind oil and water. In this demonstration, you can visualize the oil droplets reducing in size until they finally turn into a stable emulsion. As mentioned previously, the Citri-Fi is mixed with the oil first. Once the water is added, the mixing motion opens the fiber further to bind water and swell. The hydration is complete when the emulsion is formed. These emulsions remain stable over many weeks after formation. The other unique feature of Citri-Fi is its ability to provide additional functionality when it's sheared. This is ideal for manufacturers who use equipment in the process that can provide some form of high shear, such as homogenization. While many ingredients break down and lose their functionality when exposed to high shear, Citri-Fi uses shear to its benefit. Here, you can see emulsions created by hand versus 100 bar and 200 bars of homogenization pressure. The emulsions become thicker with the higher pressures or shear. This benefits many food products such as sauces, dairy, and beverages. As mentioned before, Citri-Fi has high surface area, which is not only great for water holding, but this natural fiber can also be used to turn liquids into dry flowable powders. For instance, Citri-Fi can hold 20 to 25% of oil, and in some cases up to 30% of oil, depending on the oil used. This fiber not only offers the high oil load, however, depending on the oil use, provides additional functionality when the flowing powder is used in food products. For instance, Citri-Fi used as a flavor oil carrier, which is then incorporated into a drink. The fiber stabilizes the oil in the beverage while adding mouthfeel, texture, and clouding. To dry plate, Citri-Fi in a blender or food processor and then stream oil in while mixing. The citrus fiber will absorb the oil and remain as a dry, flowable powder. The last benefit that Citri-Fi provides is gelling. Citri-Fi contains about 40% native pectin, which can be activated using the same parameters as commercial pectins. This fiber can be used to extend pectin in fruit preparations for bakery, yogurt, and beverages. However, its most popular use is to improve fruit preparation texture. In a high Brix, low pH condition, the Citri-Fi's gelling properties are activated. Citri-Fi is offered in various particle sizes, which can create different texturized fruit preparations. Recently, FiberStar introduced new technology to improve reduced sugar fruit preparations for yogurts, spreads, ice cream, and plant-based yogurts and frozen desserts using Citri-Fi. To learn more about this development, please contact us. Thank you for participating in the Citri-Fi overview. This was a lot of information to cover in a short time. You can contact anyone on this slide for more information, or you can visit our video library located at our website, www.fiberstaringredients.com. After this session, a survey will pop up. Please provide us with your feedback if you have a moment. Now, I'll turn this over to Dr. Brock Lundberg to answer any questions you may have. Thank you.
All right. Thank you very much, Dan. It was very helpful. Jenny or Dan, if one of you might be able to read the questions, I'm not able to see them on my screen. So as questions come in, it would be helpful.
Sure,
And,
I can read them off to you.
Okay.
Okay, we have a question here. It is this citrus fiber effective in oil, water, and water and oil emulsions?
Yes. Well, it's definitely more effective in the oil and water type emulsions. Up to about 60% is really where there begins to show a change in the phase. When it's above, or the percentage of water is above 60%, or I should say below 60%, the usage rates are generally significantly lower, and the cost and use is very effective because of the high oil binding capacity of Citri-Fi. It remains relatively constant up to the 60% level. Between 50 and 60, I should say, because it somewhat depends on the product type of Citri-Fi. But generally, as you go smaller in particle size, you can get closer to the 60% water percentage, and above 60%, there begins to show some change where the phase changes and there's less water available for binding the Citri-Fi, which means that there's less kind of the swelling and less functional properties for oil binding available for oil binding. So the capacity of oil binding goes down as the oil percentage goes above that 60% rate. So I think that hopefully answers the question, but feel free to elaborate more if I can elaborate more if there's other kind of detailed questions on that.
Okay, very good. Another one came in. It's, hello, can citrus fiber have good viscosity capabilities? Can it be used as a thickener to replace ingredients like cornstarch, maltodextrins? And if so, at what percentage?
It's certainly possible. There's a lot of differences, though, in the functionality and just the overall hydration between different starches and maltodextrin and Citri-Fi. First of all, Citri-Fi is not necessarily activated by heat, and typically it's very stable through heating processes, and it will hydrate and become functional as soon as it comes in contact with water. It will begin to hydrate and swell and form its functionality. It can be somewhat activated with shear, and what Dan showed in the presentation is actually the effect of high shear can really enhance the viscosity significantly through homogenization. But in the case of starches, generally, if it's like a native starch, typically it requires some heat for activation. And initially, the gelation formed with a starch would be very high, but then it wouldn't have the stability over time. And that's one of the aspects of Citri-Fi. It definitely has the stability over time and through a wide range of pH changes. So a lot of times the two ingredients can be used together. In a lot of applications, synthetic ingredients can be used with a native starch and Citri-Fi to replace synthetic ingredients to provide long-term stability, just because the mechanisms of action are somewhat complementary to each other for the stability and the way that they hydrate. But there's certainly applications where a lot of starches or maltodextrins can be replaced too. But it depends a little bit on the application, the type of process equipment that's available. So we might want to work with somebody in the technical area of FiberStar to help kind of provide some guidance on how to best accomplish that task.
Okay, and that second part of the question, it was asking if there was the ability to replace some of these ingredients. What was your recommended usage range of Citri-Fi?
Most of applications of Citri-Fi are going to be less than 1%. In fact, a majority of the applications are in the range of less than 0.5%. There are certain applications where above a 0.5% is used. And for certain gelling applications, we may go into the 1% range. But typically for most applications, for emulsification or for mouthfeel, providing texture, providing wander binding, and overall kind of moistness effects in bakery products tend to be in the range of 0.5% or less.
Okay, we have another question here. This has to do with incorporating mixing. So are there special mixing steps to activate the fiber, like heat or shear? Any special processing steps and equipment required?
It's a good question, and it's somewhat product dependent on the type of Citri-Fi that's used. Generally, the smaller the particle size of Citri-Fi, the faster it will hydrate. But in either case, shear will accelerate the rate of hydration. As shear is applied, the speed at which it hydrates will be also accelerated. And in fact, the type of shear that's used also can make a difference. And the more the shear, the faster the hydration. But it will hydrate on its own, even without shear as well. And that's one of the unique parts of Citri-Fi, is that once it comes in contact with water, it will become kind of swollen as it hydrates, which occurs just in a few minutes, even without any shear, with minimal shear. But definitely shear can be a way to get kind of a further development of viscosity, or just a way to speed up the hydration. And so there's a lot of applications where it's beneficial to apply shear if it's available.
Okay, great. I have another question about the composition. So what type of pectin is in Citri-Fi?
Well, Citri-Fi is pretty much very similar to the natural composition found in a citrus fruit. which means that it is very highly esterified. Typically in nature, pectins are formed in their esterified form, and through time and processing, they can be de-esterified. And it takes some special, I guess, techniques or intentions to de-esterify. But in the case of Citri-Fi with its natural composition, the intact pectin is, in fact, HM pectin.
Okay. I have a question about the stability. So what is the highest temperature Citri-Fi can withstand, and can it withstand freezing temperatures as well?
Yes, well, Citri-Fi would be very stable through a wide range of process and conditions and temperatures, including freeze-thaw. In fact, we have many applications where freeze-thaw stability is the reason why Citri-Fi is used. Certain rebaked products or frozen meals that are frozen and rethawed, Citri-Fi can provide that freeze-thaw stability and kind of quality throughout your reheating process, but also through a heating process in certain process conditions. We've had many successful projects where Citri-Fi provides the stability up to 100 degrees C without any breakdown at all. In fact, we do have quite a bit of water holding and viscosity data just showing some of that stability up until that 100 degrees C, and above that it really depends on the type of process that's being used, but it's a little more challenging to do those measurements above the boiling point. But typically we're quite stable and feel comfortable in the functionality up to 100 C, but certainly there are many of our customers that are doing HTST or UHT processes that are actually above 100 C. And still getting good functionality. So it can kind of depend a little bit on the process that's used above 100 degrees, but that heat stability is actually quite beneficial and a good property of Citri-Fi in many applications.
Great. I have another question. This one actually involves our product lines. So can you please briefly go over the functionalities or the differences between the different Citri-Fi products?
Yeah, I'll try. We do have several tools too, also on our website. And we have our video library, and we do have a page specifically listing the different types of products. And if you reach out to a sales rep, we do have reference guides also available that list the different types of products. So I'm going to just kind of go through the list based on kind of what's in our reference guide. So our core products that just contain Citri-Fi or citrus fiber would be the Citri-Fi 100 line, which would be through a few different particle sizes, which would be Citri-Fi 100, and that would a lot of times be used more in some of the coarse meat, ground meat applications, or even bakery products where it's okay to have a little larger particle size, and it's beneficial because it is actually less energy. It's kind of a lower cost item, but yet it has really high functionality, especially stable through heating processes, and works well, is resilient through shearing conditions. But then we do have 100 FG and 100 M40, which would be smaller particle sizes. And as you go smaller in particle sizes, the mouthfeel becomes less, they become less visible particles. And for applications where you don't want to see any fiber particles, where there's more sensitivity to any type of visual particles, such as a mayonnaise, for instance, you want to use a finer particle size like the 100 M40. The finer particle size also has better oil binding properties. And as you go smaller in size, you get a little higher oil binding. You do get a little less viscosity. as you go finer in particle size, typically. And so certain sauces or any application where you want to use and have the emulsification benefits would tend to use the smaller particle size, such as the 100 M40 or the 100 FG. We do have an even finer particle size yet, such as the 100 M20, which is a lot of times been used in certain cheese or cream cheese applications, even vegan or meat, vegan cheese type product. The TX10 is a new product that specifically we've been identified mostly for meat alternatives that still only contain citrus fiber, but it's not really targeted as an emulsifier, but used primarily for providing texture, meat-like particulates, and just added overall mouthfeel to products, especially in the meat alternatives, where it can bind water. It's a good cold binder and stays very stable throughout thermal conditions. And the TX10 has been quite effective for the meat alternative category. We do have other products that are co-processed with guar gum, which would be the Citri-Fi 200 line, which would have increased water holding and increased viscosity. So applications, especially salad dressings where viscosity is beneficial, we would tend to use the Citri-Fi 200, or the 300 line is co-processed with guar gum. Xanthic gum, I'm sorry. So 200 is co-processed with guar gum and citrus fiber. The 300 is co-processed with xanthan gum, and they have significantly more viscosity. So for certain applications, they can be beneficial, but they do have the two ingredients. So that's a little overview, I guess. So feel free to reach out to us with any specific questions about applications and the different properties and how they could suit your specific application, but that's a rundown and summary anyway.
No, that's great. That's fantastic. I have another question about emulsification. So the question is, if we have an oil and water emulsification grilling sauce without a very high shear to make the emulsion, how long would the stability last? Just an estimate.
Well, the stability actually would last for a very long period of time. It depends a little bit on the viscosity of the system. It's really all dictated by Stokes' law, these emulsions made with Citri-Fi, where the oil droplet size will definitely increase the rate of separation, and Citri-Fi does quite well at breaking up oil droplets just because of its physical composition and chemical composition. It really binds to the oil very tightly, but it also would be dictated by viscosity. So viscosity would also significantly slow the rate of separation. And if there's any gums or any, that definitely just adds viscosity, even if they're not providing surface activity to stabilize the emulsion. They do reduce the rate of separation just by viscosity. So I guess it's hard to answer specifically exactly what the number of days would be, but definitely there's many emulsions that are made with Citri-Fi that are quite stable for an extended period of time, even with minimal shear.
Great. I have a question about flavor and composition. So does Citri-Fi have any flavor, and are the nutritional components apart from fiber? Are there any nutritional components apart from fiber?
So yeah, so the typical composition of Citri-Fi is in the mid-70s for the TDF, total dietary fiber, with half being soluble and half being insoluble. And there is about roughly 8% protein in the product. So a lot of the emulsification properties does come from the protein plus pectin matrix that's present in Citri-Fi. The other components are just pretty minor. It's some minor amounts of residual sugars and small amount of oil, maybe 1% or less of fat, and then that's typically it to get to the 100%. We do have a nutritional breakdown. It does qualify as a fiber, even though usage rates are small enough that typically it doesn't add a significant fiber contribution. That's going to generally be 0.5% or less in many applications. And as far as flavors, I mean, we do a lot of washing in our process for flavor removal, removing oils, removing certain flavor compounds. That's definitely something that is quite important. We do try to make a relatively bland product. However, it is from citrus, so citrus is going to have it's very tends to be very flavorful, and so we do have certain applications where many customers do want flavor too, and they want certain flavor types, and so we do monitor flavor quite well, and we have different product flavor categories for certain customers, and we can definitely work with customers and setting up the different type of flavor objectives or properties that they're looking for.
Okay, great. I have a question about cooking. So it says, will the citrus fiber burn if used in a product that is highly seared or grilled?
Well, it is organic, so it is possible to burn the material eventually. However, it would be difficult. It would have to dehydrate the material first. So all the water would have to be evaporated off of the Citri-Fi, which would take extremely high temperatures for extended periods of time for that to happen. So kind of as a practical matter in most food applications where it's grilled or fried or otherwise cooked, generally the other components would brown or darken first rather than the Citri-Fi, just because the Citri-Fi would be one of the stronger ways, or I guess have the stronger affinity to bind both water and oil, and it would help to prevent or reduce some of the darkening just because of its greater tendency to bind to water and oil. And but I mean, eventually at some point, yeah, it certainly is possible, but it's just not very likely or practical in most applications for it to darken.
Okay. And we have one more question. This one is about samples availability. So, oh wait, we have another one after that. But this one has to do with sampling. So, are there TX10 samples available?
Yes, definitely. The TX10 has been quite exciting for us. It's relatively new. So we're continually kind of working with the customers and trying to get the exact properties for different applications. In fact, we may end up just coming up with new varieties of it for certain applications because of the high degree of customer interest. But that said, we definitely do have samples available.
All right. Another question. This looks like is, would Citri-Fi be able to mimic the properties of Panadin? Panadin looks like it's a datum emulsifier. It's brand name.
Yep. It depends a lot on the application. I know datum's used a lot in bakery applications. So we do have many applications where Citri-Fi is used in bakery as the emulsifier, including replacement of monodiglycerides, including datum and other emulsifiers. So it certainly is possible, and we do have some guidance on how to get started on formulating such a product, and we do have several technical bulletins, so reach out to us and we could share that with you so that you can use that as a reference. And kind of what you'll see is that Citri-Fi would bind significantly more oil, therefore the usage rates would tend to be significantly less. And that's just an important consideration when replacing other emulsifiers. It's beneficial typically because of its cost and use. And want to use one of the smaller sized Citri-Fi, 100 FG or 100 M40 would be one of the more common types of Citri-Fi because they are more effective at emulsification.
Excellent. And I think that pretty much wraps up all our questions today.
Okay, thank you. Excellent, this was good. So I guess if there's any other follow-up, we do have the contacts listed here on the screen. And with that, we will end this webinar and have a good day.